Hello and welcome back at the second part of the tutorial, when in the first part we covered an installation of the required development tools, and in the second part we will focus on setting up a node as a participation node together with installing some useful development tools. Another important configuration which we need is, of course, we want to make a local wallet. So we can make a wallet using again the call command new. We can call it my tutorial like this, and we want to of course again use it for our testnet data node which is already running. It will take some time. We want to also set up a password, so we can call it test123 because it's only for testing purposes. You can call it as ever you want. And as we know, also for each wallet is also created a backup phrase, and of course we would like to know. And as a best practice, we don't want to show this to anyone, same as of course as the password, and we want to keep those really in a secure place. So now when we have a wallet, we also want to create an account. So how do? We do account list -d, and we use again testnet data, and now it will basically create an account for the given. So now it will basically list the available accounts for this testnet data. So currently it will be empty, and we want to create a new account for the corresponding wallet. And as expected, there are no accounts, so we again use the goal, and this time we want to create an account with -d, and again for testnet data. Now we see that an account has been created, which is this long name. This will be of course important for us, for example, in case we want to send some algos. And this is exactly what we want to do. So since we are on the testnet, we of course need some algos on our network. What we can do, we can use the available feature of the dispenser of free algos for the testing purposes. So we have to firstly verify ourselves that we are not a robot. So we have to find the hills. I hope these are the hills. This looks like a hill. And we were successfully verified, and we can copy here our account information and hit dispense. We see that it was successful. It's important, and now some algos are on the way to us. Going back to the terminal. Back in the terminal, we want to see how is the node regarding catching up. So it seems like it already caught up, so it's really good. So we see that the algo still didn't arrive, meaning that we are still actually not necessarily catch up with the block, so we have to wait for some time, but it will appear eventually. In meanwhile, what we can do, we can also have a look on the configuration JSON file to see which fields are in there. So we can go to the data, and we can look for the config JSON example. And here important parts for us, as we were describing before, you see that by default the archival mode is set to false, meaning that we don't store all of the blocks on our node, but we only store the snapshot of them, and which is basically the last 1000 blocks. So of course, in case we want to do some larger operation on some data, we have to contact to the relay nodes which store the whole blockchain on them due to the space reasons. And another important stuff is here, DNS bootstrap. We might talk about it in some other tutorial, which is important in case you want to use not the testnet, but you want to use the betanet. You would have to here set it to dev, which will be basically later on pointing you to the betanet network for the development purposes. Great, and now when we know that we have some algos on the way, we can start with preparing the registration of our node. So firstly, we need to create a partial or the participation key, and for it is important to have in mind the last committed block, because our participation will basically start in the future. And looking at the syntax of the participation key generation, so we basically have to provide the information about the address of the participation key account, which fortunately I have stored in our dispense. So this is this information, otherwise we could get it from somewhere else. We need the first round when the key should be valid. So this is the part of, let's say in case we have 1, 2, 4, 8, 5, 4 to 7 some minutes ago, so maybe we can change the last digit to make it valid at transaction 6000, and we will make it valid for, let's say, 1000 or maybe 2000 different transactions. So we can call it 1, 2, 4, 8, 7, 0, 0, 0. So this will be basically from when to when this is valid, and the key dilution value should be computed, or is recommended as a default value, is around 10,000. Part, which is this one. And now we see that the participation key was generated successfully, and we want to check if the participation key was generated. So we run it on our testnet data, so we see that it was successfully generated from when to when it's valid, for which account. This is important. And in the next part we want to also have a look on the additional information about the key. So let's have a look. We see here that basically what is the provided parameters we have, and other parts of the description about the account, and so on. Next, what we want to do, we want to create the online transactions, which is basically the part which will be later on sent to all the other nodes, to where we basically say that, hey, we want to join the network, which is in the following form. So we have the address, change online status, yes, and how much is the fee? It's a fixed fee of 2000 microalgos, and here is important to use the same values if we did for the registration. So the first wallet is this one, and last wallet is equal to this one, and we want to change the online status to true, meaning that we want to join the network, and the transaction file will be called txn, but it's a typo, it should not matter, because again this is not finished. And we forgot to again mention the part about the testnet data. We are provided to provide a password, so we provide our password. Now we want to check if the transaction file was successfully generated. So we see that it's exactly here. What we can do to make it clear, so we can move it txt to online.txn, which stands for transaction. And now, of course, this is not enough. So now we basically just generated the transaction, and what we have to do with it, we now have to sign it using our private key. So yes, here is a typo. Now we have to, we again forgot to specify for which node we are talking about. So we have to specify the testnet data. And now we want to check that the transaction was successfully signed. So yes, we see it here. Great, and trying to send the final transaction. We see that the transaction is issued, still pending as of the current round, but hopefully will be accepted in the successive round. Great. With that, we went through the part of registering the participation key and also putting it on the chain. So now basically our node is active and we can verify it easily by checking the following. So now when we are checking the account list, we should see that the status should be changed from offline to online. And as expected, we see that now the status is online, and also we see that the algos which we sent to our account are in place. Great, with that we registered our node online, and going back to our slides, we basically covered all of the important points. Just to mention before finalizing, in case we want to have our node active, it's important that we basically regularly generate the participation keys, and we always have to send a new transaction when we generate them to be basically later on part. And in case they expire, basically our node will not be trusted anymore and will be marked as a dishonest, and therefore it's better to keep the node offline in such a case. And in case you are, for example, moving or something, or for some short period of time also your node is not online, just mark it offline, even though, for example, the keys are not expired, but basically in case it's offline, just mark the node offline, basically follow the best practices. And of course, as you could see, we were using our private key, which is currently stored in the wallet. So in case you want to protect your system in a better way, you can store this private key in some cold storage. You can pre-generate the transactions, as we did now, that we basically pre-sign the corresponding transactions. You can do it in large numbers. You can again then store your private key in a cold wallet, and later on you can be just issuing the corresponding signed transactions as we have done now. So that way you basically protect your assets but still can contribute to the robustness of the Algorand chain. Now, when we have our Raspberry Pi set up as a node, let's dive into the part of installation of useful development tools. Namely, we will be installing Python 3, Node.js, and JavaScript Algorand SDK. So before diving into the code, let's firstly go through the dependencies which we have to install briefly. So of course, before we want to start any installation on the Linux-based system, we have to run sudo apt-get update. And in the first phase, we download the Node.js set up in the long-term support version, and we install it on our system. And after doing this, we should see that we have successfully installed the version of 14 point something, and with that we basically have a Node.js installed. And this is basically later on immediately used to install the JavaScript Algorand SDK using the npm command. And finally, the final dependency which we need is to install Python. And unfortunately, installing Python from the package manager right away on a Raspberry is not, it's possible, but it's not optimal because the official package is quite behind the latest version of Python, and therefore it's recommended to install the latest version manually. And for that we have to follow these steps: that we firstly install the Python 3 pip, and then we navigate to the user src to download the latest version of Python, or the version which we want. We have to of course untar it, and now when we have the package download and untarred or extracted, we also have to install the additional dependencies which we can see here. And in the next phase, after we install the dependencies for the installation of the Python package, we navigate to the directory itself, and we start with the configuration of with the enable optimization. So basically this will prepare the files for the later on execution of the installation. And after installation, we use a symlink to point the installed Python 3.9 to the Python 3. And with that, running the command Python 3 should return the Python running in the version 3.92. And we also, of course, want to do a bit of cleaning, so we clean the downloaded file and also the extracted format. So to conclude, We have learned what types of nodes are in Algorand network, where we have installed a non-relay, non-archival participation node on a Raspberry Pi. Next, we also learned what type of networks are available in Algorand network, where we have used the testnet network to basically connect our Raspberry Pi to it. We learned how to join such a network, and most importantly, we learned how to manage our participation keys. So please do not forget, if you're going to contribute to the consensus algorithms, mark your node as offline. In the final parts, we installed our first Algorand JavaScript SDK, along with some other useful tools for the future development. Thank you for watching, and feel free to raise any questions and connect.